Hey guys, welcome to the session. In continuation of the BGP path manipulation, in last session we have done discussion about how to manipulate the path based on the AS number. We know that we have a lot of attributes. So we are trying to do all attribute one by one understanding. So in last session we understand how we can configure that particular lab topology step by step. We run the HSRP, we run the OSPF in between the devices, and we run the eBGP here, and also we run the iBGP between this section and eBGP between this section. Again we run the iBGP between these two routers, right? And via OSPF we make the reachability, and we advertise the route, and we give the preference of the path, right? Instead of this path we have given the preference via this path using the local preference. So one thing you by using the AS path. So AS path, basically the attribute that is going to be that is going to travel from one AS to another AS, right? This is the one set of the attribute. Remaining other set of the attribute will discuss who is going to travel from one AS to another AS. Let's suppose I am just configuring one BGP AS here, and this AS number having this AS number like 64001, this one having this 6455, and this one having 64002. So if I'm going to advertise any BGP route with this AS number, it is going to carry entire AS detail till last hop of the BGP peer. Okay, so it is going to cross or travel the multiple AS of the BGP. All right, but the next attribute which you are going to discuss, and that attribute is not going to carry the prefix from out of the AS. So one thing you just also have to understand, the local pass is going to influence the inbound traffic or outbound traffic. So there's a very misconception we have along with the multiple students, right? They always think which kind of the influence or like the manipulation is going to be happen by using the BGP AS path prepend. So you try to understand in previous scenario what was happen by doing the AS path manipulation. So what we have done means, I want this subnet or this PC should be reachable primarily from this path or might be this path. So let's say by default it was taking this path. Let me see that. And but I want to use some, or we can check the vice versa. I believe we have done the vice versa settings. So earlier when I was trying to trace the DC subnet, it was going via this path. But when we did the manipulation, it will start taking this path and it was reaching to the destination DC address. So how it was happen? So from this point of view, think about, we did manipulation AS path prepend from this AS number, that was data center, and from there we send the out prefix with the higher AS preference, right? Highest AS path prepend we have sent from the data center. But when this received the prefixes between these two routers, so what was happen? This copy of route was received on this router with AS4 time AS prepend, right? The AS path was prepend 4 times, right? But this was by default no AS prepend, right? So earlier based on the default it was saying this path, but based on that this path start getting the higher AS prepend, and this was not getting any higher AS path prepend. Then this path is start getting primary to go out to the destination. So basically from this point of view, it is influencing your outbound traffic. Understand? Means when I'm going to out from my network, then AS path is influencing my path. AS path is influencing my path to just go out from the network. So basically with the help of the AS path, we can influence the outbound traffic. Okay. So anything, just you have to think from where you want to access. So if you are sitting on the site and you want to access your data center network, and that are two data center, so you are going out from your network. So based on the AS path, you can make DC1 as a primary, DC2 as secondary. So from DC2 you have to prepend AS details, right? From DC1 you don't have to do any prepend. So that by default shorter AS path is going to take in a picture and it is going to influence the path. Similarly, if we have to do inbound, right, inbound manipulations, so how it is going to happen inbound manipulations? So for doing the inbound manipulation, as we have the multiple like attributes, if I'm going here BGP attributes, So we have the multiple attributes, and these attributes are basically going to match one by one. So see, we have the wait local preference. We done discussion about the AS path. AS path is going to help you to do the outbound manipulation. But if I talk about the wait and local preference, we'll focus one by one all the attributes, but we are talking about the wait and local preference. So right now I'm going to talk especially for the local preference. In next session, I'm going to talk about the wait. So wait basically going to influence again, it is going to influence your outbound traffic. But how it is going to prevent outbound traffic? This is influencing your traffic is coming, but just you have to think about directions. Let me show you again. AS path, basically your traffic is coming higher AS path from this neighbor and lower AS path from this neighbor. So basically this traffic is I am receiving in. So based on that, if I'm trying to go out, this path is getting preference, right? So I'm going out, but it is manipulating my inbound traffic. It is coming. Whatever traffic I'm receiving, I'm just receiving based on the AS path prepared, and it is manipulating my path. So how local preference is going to come in a picture? So local preference, first you have to think local preference attribute is basically it's a not well-known mandatory attribute. It is not well-known attribute. It's the well-known discretionary attribute. If it is well-known discretionary attribute, that means it is not always going to carry along with your BGP routes, but AS path is always going to be available with your AS detail, always going to be available with your basically all routing informations. So local preference again going to help you to just manipulate your outbound traffic. But how it is going to apply the outbound traffic? So basically, if you are thinking for the local path preference, let me just log in it. So if you are thinking about the local path preference, so this local path preference is going to stay within the AS, means local path preference means the AS path and local preference is two different things. Local preference is always going to stay within the AS, but AS path is always going to travel like multiple AS. That is one concept. So if I am going to configure LP, it is going to always stay within the AS number, but AS is going to always apply to the multiple AS number. This is the one concept. By default, LP having the value is the 100, means local preference value always going to be 100. Okay, by default. If you having the higher LP, then the route is going to be preferred. Okay, similar to the AS path prepend. If you have the longer AS path prepend, then it is going to preferred. If it is a shorter, then it is going to be preferred, and longer is going to be less preferred, right? I just told the opposite thing. But most important, you have to understand direction. I'm talking about again your AS path is influencing your direction of the outbound traffic. But you have to think, is it really to influence the outbound traffic? Technically, it is going to influence your inbound traffic, and local preference is going to influence your outbound traffic. How it is? Then this statement. So if I'm going to write here AS path, always having the confusion about the all engineer. So AS path is help to influence the inbound traffic. But if I am talking to local preference, right? It is going to help you to outbound traffic. So what does mean? How this inbound is going to come in a picture? So you have to think about when this prefix I am receiving, once this prefix is getting advertised, right? From data center point of view. So I am advertising from these routers either via this and this. So by default, it was taking the default AS number and it is reaching to this and it is reaching to this. So based on the tiebreaker, it was selecting this path to go out, right? But once I did the manipulations, then I'm saying that to this router, you have the higher AS path prepend value, Okay, and because you have the highest AS path prepend value, then how it is going to be happen? Then you are inviting me, means I'm going to come you not via this path, I'm going to come you via this path. So I am saying, just think about data center point of view, how it is going to become the inbound traffic manipulation. So this scenario is going to come in case when you have these two branch location, let's say, and you not have the control of your ISP, and you want to make sure this R2 is going to become your primary. This R2 is going to become a primary, and this is going to become a secondary. So one thing is there, if you are going to say ISP, like you do the prepend and you do the prepend. So to doing the configuration, basically they are going to ask you the money, or maybe they charge, or you have to write a lot of email communication to do that particular changes, because the config changes are not like on fly is going to happen in the ISP network. So in that scenario, you have to do something. By using that something, you can prepend your AS. Based on the prepend AS, let's say suppose someone from outside, let's suppose some sitting here is a server, he want to access your LAN network, then it is coming into my network, either this path and this path. This is your inbound traffic. So you just have to understand the direction. Initially when I was explaining, I was keep talking the outbound, because you have to think about directions, you have to think about the use case, why AS path is manipulating the inbound, and how it is going to look like as outbound as well. Always confusion is there, because you never thought about what is my directions and what is the use case. So use case is, if let's suppose I have the ISP network, I don't have control on the ISP network, but still I want someone should come my LAN subnet based on my preference, then AS path is going to come in picture. How it is going to come in picture? See, this is my LAN subnet. I am going to advertise this LAN subnet from this router 0/24 as a AS path. 4 times I am going to prepend. 4 times AS prepend is going to happen. Here, no, just default I am going to leave. So this route is going to reach on this P router. This route is going to reach on this P router. So now this P router have two copy of route. One route it is receiving 192.168.10.0/24. This is coming from this with 4 AS number, right? Or might be the 5, because it is going to take on AS also. So let's suppose 4 prepend, 5 now. But this is coming with the same routing table 192.168.10.0/24. It is just going to come as a 2 AS numbers. So now this router have to decide which route I am going to install in my routing table. So definitely which have the shorter route, shorter AS path, then it is going to install in the routing table. So this PC is going to always take a path to reach to this site via this one. So basically I am going out from this site of point of view, but when this traffic is reaching to this network, this is actually influenced you to just come via this path. So it is inviting in my LAN network. So that's it's become the inbound traffic manipulation, because based on my manipulation, you coming to me, I'm not going to you. I just manipulated my network, you coming to me. But if you think about this direction, it is look like I'm going out from my network. But you think from this direction, you invited someone come from this door, not this door. So this is known as their AS path prepend is always used for the inbound manipulation. And how local preference is going to be used. So right now I am in this particular network. Let's suppose that I want to go on this particular router. Let me go on the P router. So P router, I'm just going to check it. Show IP BGP 192.168.10.0/24. See, this route is receiving from this neighbor 89 dot, sorry, this one 89 dot this. But let me shut this particular neighbor. First let me check what is my BGP summary. Show IP BGP summary. Yeah, this neighbor is down. I don't know why it is down. Let me check on this particular P2 router why it is down. Show IP BGP. First let me BGP make the up and working. So it is active. Why? So ping 79.0.0.1. It is not pinging. Let me ping like this one as well. Then after I'll check the IP address. Something went wrong. Let me check on this particular router why it is not pinging and all. So let me check show IP interface brief. Okay, interface is up and working. Let me check here, show IP interface brief. This also fine. So let me do one thing. Let me, because it's a virtual thing, so let me simply give 0 3 by 3. Let me delete this. Let me add this again. Sometime this kind of issue always going to be happen. So it's normal things. And 2 and 2. Let me off this router as well. Delete this link. And let me add this one also. 2 and 2. Probably it is going to fix the issue. So what is going to happen by default? It must be having a true path, but which path is going to come in a picture, because there is no manipulation right now. So by default it is going to take the default attributes based on the tiebreakers, and it is going to take one path to go out. It's not like one packet is going via this, one packet is going via, it is not going to happen in this case BGP. Either it will going via this path or either it will going via this path. So we have to manipulate. Now you have to think, this time I'm talking about the AS local preference. Local preference is something, this local preference value is always going to be used. Higher number is preferred, lower number is not preferred. So let's suppose I'm getting one route from here, from this neighbor, and I'm just going to get LP as a 150. One route I'm getting from here, and this LP have the 100. So this path is always going to prefer to go out. Means from this PC I want to go out over this network. Then within AS I'm going to use the LP to just preference that manipulate my path. So this 150 is going to come in a picture, and this is going to like run between the AS number. So anything is going to out, it will already take this path. So LP is always going to use for the outbound manipulation. AS path always going to use for the inbound manipulation. You always have to note it down. Okay, I'm going to show you. So let me see if this router is up and working. P2. So show IP BGP summary. Yeah, now it's the up and fine BGP. So now let me go on this particular router and let me check show IP BGP 192.168.0.0/24. So still have the one path. Let me check show IP BGP summary. BGP is up, but that is not receiving any prefix. Might be, let me check P2 again. This is not getting any route. Okay, now it start getting route. So probably this also start getting route. Yeah, so now if I check, so let me check again this command. You see this route start getting from both path, and see now the best part it is selecting based on the lower router ID, the 79 automatic. Earlier this path was not there, so it was going via the this path. So you can see by default both having the same local preference. You can see local preference 100 here, local preference 100 here. So there is tiebreaker. If there is a tiebreaker, then it is going to follow the like next, and it is going to break on the neighbor IP address, lower neighbor IP address, which is going to be win the situation if there is no router ID. So neighbor ID, you can see this is 79, this is 89, so it is lower than this 89, so it is going to win the race. But now I have to manipulate the path. If I want to go this PC, I want to go not via this one, I want to go via this one. So I am going out from this data center point of view. I am going out. So this is the outbound manipulation. So I have to configure the local preference. How it is going to happen? First, I want to go one prefix. So I have to make sure just that whatever prefix I have, that should be matched in my prefix list as well. So let me create IP prefix list, IP prefix name, LAN subnet, and this LAN subnet is 192.168.10.0/24. Omit, sorry, omit, and this is my prefix list. All right. Now I have to give the route map, right? Route map LP, or you can just put the name as a local preference. Omit 10, just put a omit 10. What I want to match IP address prefix list, and this is my LAN prefix list. Basically this is not required here. Let me create it. This need to be configured in the P2 and P4, because we have to manipulate the path from there. Just give me 1 second, guys. Sorry guys, so I get an urgent call. So I was talking about the match IP prefix list, LAN subnet, right? And we just have to create here. Hold on, what happened now? Let me see, something went wrong. Okay, so match LAN prefix, right? And then we are done. Set local preference, right? What local preference I want to set? So we just have to make one side 150, another side it is going to take a default. So this is the route map we created and prefix list we created, but this is not required for this particular on router, right? This is required on the P4 and P5, because they are receiving the prefix and then further they are going to send in the LAN segment, right? So let me use. All right, so this is my route map. So what I have to do, I just have to use this copy. I will go on the P, because these routers are receiving the prefixes from this neighbor and this neighbor. So once they receive the prefix, okay, once I receive the prefix from this neighbor, because this prefix will receive from this neighbor, this will receive from this neighbor. So this configuration, what I have done, actually wrongly I make the wrong router. I should be used on the P2 and P4, but without notice I make on the P router. So I have to do this configuration because I want to make this router as a primary, this router is a secondary. Right now the traffic is going via this path. Let me make you the trace from the P router so you guys understand. So if I am tracing right now 192.168.10.1, so you will see that the traffic is going via this 79, 1110 and then 30 subnet. You will see that in the trace, but we just have to manipulate. I again did trace from the wrong router. Let me do from the right router. Actually I make the wrong thing, so let me make from here. Sorry for that. So you will see that actually P is the actual from where I want to check the end-to-end traffic for the manipulation. If I'm doing from the P router, that it will take the one path to just go in the C side. This will take directly this one because there is no relation between this. Okay, so just wait. It is going in a 79. Okay, then it will go on the somehow this trace is not working. Let me check it. Show IP route. We are getting let me ping some physical IP address. Let me ping this one. Virtually I believe this is not reachable. Let me try to ping the physical IP address. We'll see. Maybe the virtual there would be some issue. Let me see the reverse route on C1. We are getting or not. Let me check. Okay, so I understand why it is not pinging, because by default it is taking a source of these interfaces 79 and 89, and these source are not advertised in the BGP. So we should take the source as a 1.1.1 or 2.2.2 because they are in the BGP table. So if I just check here, show IP route, you are not going to find the route from the 79 and 89. You can see here, there is no route. We are getting from this one. So we just have to use the right source as well. This is also very important. Okay. So let me change the source. Source IP use 1.1.1. This is advertised end to end. So it is going to see, it is ping is working. So now if I'm going to do a trace with this source, the trace is also going to work for me. So I was doing something without source. It was taking a default source. So this kind of problem also you have to identify, because I'm making some mistakes today due to various reasons, right? So probably it is a good sign also, guys, you understand what kind of the issue can be happen and how it can be rectified. So by default, if you are not using the source, it is going to always take an exit interface of your router. So it is taking this one, and that is not good. So now you can see this is going to this, and then 110, this is the path here. So what is the current path it is taking? From this router, it is going to this and this, because this route I am receiving 100 LP also from here, 100 LP also from here. So these are the both tie breaking. So lower neighbor ID is taking the preference as a tie breaker. So that's why it's reaching the destination. Now I have to manipulate. This should be go via the 200. So I have to make sure when I receive the prefix from this particular neighbor, and when I send back to this router via the IBGP, I will set LP as a 150 and it will set LP as a 100. So when this router will receive the 2 copy of the route, 2 copy route, this will install the higher LP value, not lower LP value. Okay, so let me make this happen. So if I go here, I'll just copy the commands which we run earlier, because already we created this local preference. I'll just use this same concept, 150 local preference. I'll go on the P4 router. I'll go on the P4 and I'll copy this command. Same, you have to create one route map which is going to require. This is how you can create the route map, and also you have to create one prefix list, right? So this prefix list we have to create this one. All right, so it is just going to match the one prefix because we are playing around the one prefix. Now go on the BGP neighbor, show run section BGP, and BGP neighbor, from where I am receiving the route? I am receiving the route from this neighbor 200. So I'll say it, when I receive the route my in, I'll apply the policy, I'll apply the route map. So my route will get the local preference apply 150. Right now if you see that this is the neighbor, there's nothing is configured, and that's why you can see in the P router show IP BGP, if I am running show IP BGP 192.168.10.0/24, these are getting this is getting best, both LP is 100 and 100. So I have to make this path as a most preferred. So let me go on the P4 go in the already I'm the configuration. I'll go in the router BGP and 6455, and I'll go in the neighbor. Which neighbor? Because this is receiving the route. From where I'm receiving the route? From this neighbor I'm receiving the route. So I'm going to say when I receive the route, which route? 192.168.10.0, right? I'll apply the route map. In the route map I'm saying I am receiving the route. See, in the route map I'm saying match this prefix list, and once I'll match, I'll set the local preference 150. Okay, so route map, what is the name of? LAN subnet. This is the local preference, not a LAN subnet. And which direction I need to apply? So because I am receiving the prefix from WAN to LAN, so I'm sending, when I receive the prefix in, then you set the 150 LP. So it will coming to the P router, that is the 150 LP, and this C will send as a 100 LP. So this will always going to tell this as a best route. So let me apply in the in direction, and once we apply the in direction, it is going to manipulate your outbound traffic. So that's it, means we are going to out. So let me see that this is my P4. Now I'm going to the P router. See, if I just going to run this command, now still not change, it will take a little bit time, or you have to clear the route. Clear, you can just run the command clear IP BGP *soft. So it will clear the route and then it is going to install the best route. So still not. Okay, so let me go on the P4 router also, and let me clear IP BGP star sock. So all neighbor is going to be clear. So they will advertise the latest update. So let me see again, and see now the route has been changed. You can see, follow, this route has been installed in the routing table 115. This is the 100. So now if I am going to check the routing, if I am going to check the routing of this particular router, show IP route, you see this 192.168 start learning from this particular neighbor. And if I just run the trace again, trace 192.168.10.1 with source 1.1.1, you start seeing earlier trace was going via the 100.neighbor, but now it should go via the 200 because we manipulated the path. So this is known as the local preference manipulation. This is always going to be like locally within the AS, local path always going to apply inbound direction of the eBGP neighbor, but it is going to influence your outbound traffic. AS path is going to send, like AS path, you just have to advertise your route in the out direction to out of the world, but once they start coming to you, that is going to become traffic as a inbound influence, like the manipulation. So if you are going to apply the out direction, that is going to influence your inbound traffic in case of the AS path. Local preference, if you are going to apply in the inbound direction, it is going to preference the path of the outbound direction. So LP always for the outgoing traffic, but you have to apply in the in direction. Why? Because you have to change the default attribute value. AS path, it is going to influence your incoming traffic, but it is going to apply in the out. So you just have to remember this one. So I believe you understand. Next we'll understand the attribute, but let me show you. This is your all traffic. That is the next attribute you are going to understand is the weight. We'll see what is the weight significance and how it is going to apply. This is your trace. So trace has been manipulated, your route has been manipulated. So this is about of local preference manipulations. All right, I hope it is clear to everyone. So in next section we'll discuss about the weight. Thank you.